Hi, welcome back. We're going to talk about Chapter 7, Pesticides and Other Organic Chemicals. Okay, I'm just going to talk about some of the bullet points. Okay, because it's an extremely big chapter. Okay, keep in mind that you have a midterm exam number 2 next week. Do not forget that. Okay, it will be available on Friday next week and will be available until Sunday. Okay, it's exactly the same format as it was for midterm exam 1. Okay, coming to the chapter. Okay, so we're going to talk about pesticides. There are 4 classes of pesticides. The first class is organophosphate, second class is organocarbamates, third class is organochlorides or organochlorines, and the fourth class is pyrethrin. Okay, what are the different peculiarities of each of the classes? Each of the class. The first is organophosphate. Okay, by far it's the most common class that has been used for pesticides. Okay, uh, organophosphate pesticides. When I say pesticides, they could be insecticides or herbicides. Okay, herbicides kills plants, plant products such as grasses, weed, and other shrubs that are unwanted. Okay, and animal products are basically insects, rodents. Okay, worms. These are the insecticides. Okay. Okay. So now insecticides only for insects, rodenticide for rodents, and what's called nematicides for worms. Okay. Okay. So there are general type of pesticides and there are specific type of pesticides. I just said about specific type of pesticides, insecticides, insecticides, nematicides, herbicides, and so forth. There's a general class where it's a general insecticide, which means it can kill not just insects but also rodents and other animals, not herbs though. So that's a general class of insecticide. There's a general class of herbicides as well. Okay, so organophosphate is a general class of insecticide. It can kill. It can kill different types of pests such as worms, small animals such as rodents uh, and obviously insects as well. Okay, so that's the general class. So organophosphate are used in the different types of uses, and they are available. They are most universally used pesticides, type of pesticides. Okay, the second class is organocarbamates. Carbamates are similar to organophosphates with the difference that they dissipate into the environment very easily. Okay, compared to organophosphate. Organochlorides is a third class, which is basically banned. It's a DDT that you might have heard of. So DDT type of pesticide, they're banned because they cannot be degraded very easily into the environment. Okay, so they have some toxic qualities, and they cannot be destroyed very easily into the environment, and that's why they remain in the atmosphere for a very long time, and they can also bioaccumulate. They can remain in the blood for a very long time, and they can make people sick. Because of that, that class is banned. Number fourth is a pyrethrin. Pyrethrin are the type of pesticides that have animal or plant origin. Okay, other 3 classes have purely synthetic origin. They are created artificially. So the mixing of the chemicals. Okay, while pyrethrins are the mixing of chemicals, but some chemicals are coming from animal or plants. So that's why they have some biological source. So those are pyrethrins. Okay. Um, so you need to know how the pesticides work. Pesticides work by killing the pest's nervous system. Okay, so basically, uh, it affects the end-to-end and signaling system by affecting cholinesterase enzyme activity. Okay, so just imagine that uh, this is my brain and this is my hand, and I want to write something. So I want to lift my hand first. Okay, so the brain gives the order to the hand to lift. Okay, now once uh, once the order is received, the hand will lift the hand, and then once the order is basically utilized, the hand should go back to its normal pace, what it was doing, or waiting for the next order, which is writing or something like that. So basically, one cell, the message or the order transfer from one nerve cell to the other nerve cell. So brain's nerve cell, and then it's chains of huge network of nerve cells, and finally ending to nerves of hand, and ultimately the order is utilized. I mean, the order is implemented. Okay, so uh, what the pesticides do is that uh, it basically messes up the chemicals. Okay, so acetyl and choline are free flowing chemicals in the blood. Okay, in order for a brain to give order to other organs, the acetyl and choline should come together, and then they can transfer the order from one cell to other cell. Okay, and once the order is transferred, the acetyl and choline should break apart, go back to their normal place, and then the the organs, the receiving uh, extremity or whatever organ should go back to its normal routine or whatever it was doing before. Okay, so to break apart acetyl choline into acetyl and choline, there is an enzyme that comes into picture. It breaks them apart, and then the organ go back to whatever it was doing before. Okay, so this is normal situation. What happens is that pesticide, they kill the activity of cholinesterase enzyme. So what happens is that acetylcholine is not break apart into acetyl and choline. So what happens is that there is a buildup of acetylcholine, and when that happens, the brain does not. I mean, the brain thinks that maybe the organ, or in this case hand, hasn't got the signal, so the brain tries to send the signal again. So it keeps sending the signal. It keeps sending the signal because the acetylcholine is not broken apart into acetyl and choline. The signal, yeah, the message that comes there to the brain that okay, the signal has been received, so stop sending the signal. It's not done. So the brain keeps sending signal, and what happens is that then in this case my hand will be like lifted like this, and then this like it's a moments like happening like uh, uncontrollable movements of hand, and finally what happens is that because brain is sending the signal, and this happens very fast. So what happens is that this shakes up the entire nervous system, and finally the nervous system gives up and is a nervous shutdown, literal nervous shutdown. Okay, and then the animal dies. Okay, so that's how the pesticide works. So it impairs the end-to-end signaling system by killing the activity of cholinesterase enzyme. So what they refer as anti-cholinesterase activity. Okay, so this is the basic of that. All pesticides, they work in this manner. Okay, they use a medium such as sodium or calcium, so sodium ion blocking, sodium channels, things like that. So it's basically just a medium. like a message is transferred into in a letter, right? So letter is a medium. So the sodium and these ions are medium. Okay, so that is the basic of this carbamates. Okay, you need to know that methyl isocyanate is a precursor of carbamate, which means that it's an intermediate product. So when they create a pesticide in the factory, two raw chemicals, they mix they mix them together, heat it up or whatever they do, and then there is a chemical reaction. Then you have like first the desired product, and then there's a byproduct. Okay, you take that desired product, mix another chemical, have some reaction, and then you get a final product. So the first product you got is an intermediate product. The next product is that you're getting is a final product, which is your basically the product that you're selling and things like that. So pesticide, carbamate, which is extremely safe. There is no problem with that. So it's not as bad as DDT. It's very safe because it's degradable very easily into the environment. So it's very safe to use, and it's been used. You can use it in garden and things like that, and you can. So it's so what happens is that it's precursor methyl isocyanate. So it's an intermediate product. It's extremely dangerous, and there is accident of that happened in 1984 in Bhopal, India, where the methyl isocyanate was stored, and next day it was being used to create a final product, the carbamates, and it's basically a gaseous product, and it was stored into the pipes, and the pipes broke, and the methyl isocyanate came out and get into the environment, and it killed like around 3,000 people in their sleep, 3,800 people in their sleep. I mean, it's just, the figure is extremely underestimated. There's many people that were killed in the city of Bhopal, India. So it's a huge tragedy. So you can see that intermediate product could be extremely dangerous and can have a ability to kill so many people. Okay, so that's carbamates. The next one is the organochlorides. Organochlorides, it's DDT. They're very toxic. They bioaccumulate. We will learn about bioaccumulation. The bigger the species is, the more exposure of the chemical, more the chemical that is stored into their fats or other organs. So you get a lot of exposure. Everybody of us has some content of DDT in our blood because it was spread in 1940s, 50s, 60s extensively. In 1940s and 50s, it was used as regarded as a boon because malaria was extremely dominant, and for malaria eradication was going on, and DDT was a great that worked it, and basically 1949 we came out of a malaria epidemic because of DDT, largely because of DDT, and also of course the drug treatments and everything. So it was good for vector control, but what happened was that in 60s and 70s we came to know that DDT is extremely toxic to the environment because it's something called a POP, persistent organic pollutants. Okay, so those cannot be degraded very easily into the environment. There are POP, persistent organic pollutants. So then it was banned because it can cause different types of cancers and so on and so forth. Causes abortions and problems to the development of the kids, and very different types of adverse effects. That's why DDT was DDT was banned. Okay, the last one is pyrethrin that we talked about, coming from the natural origin, and they are extremely wonderful to catch flying insects, and they are very because they have animal source, so they are safe to use. So natural source, they are safe to use. So there are 4 different classes of pesticides. We have other chemicals such as dioxins. They are very bad. Okay, the herbicides. Herbicides, we need to know about Agent Orange. Agent Orange is a chemical that was used for the Vietnam War, not World War, in Vietnam War, to clear out forests in Vietnam because it was difficult to have warfare, and there was and the guerrilla warfare was activity was conducted by Vietnamese soldiers. So the foliage, so a lot of forest was coming in between, so they sprayed a lot of Agent Orange to clear out the forest, and then it was exposed to both sides of the soldiers, and when the US troops came back home, they had chemical hypersensitivity and disease of eyes and skin irritation, eyes irritation, and there is a huge chemical insensitivity that happened. Also, many people got different types of cancers because there was a tiny amount of dioxin in it. Okay, that comes to dioxin. Dioxin is 419. It's a group of 419 chemicals. Out of that, 30 chemicals are extremely poisonous, and dioxins are usually created when you burn something. So, incineration of waste, fuel burning, even tobacco smoking, it can create a tiny amount of dioxin. Dioxin are very bad. They can cause different types of cancers. They are bad for skin, so chloracne and different types of skin related problems, hair growing on skin, liver disease, and different types of even metabolic problems, hormonal problems. Everything that can happen from dioxins. Then we have talked about the plastics. There are two types of plastics. One is styrene. Styrene is one of the content that is used for plastic manufacturing. Styrene is regarded as a possible carcinogenic, can cause cancer. So polyester resins, they have a styrene. So some types of plastics, they have that, and it's a possibility that they can cause cancer. So it's worth considering. Other one is vinyl chloride. So PVC pipes that you guys use, I mean, all of us use in our home. In modern days, it used to be metal pipes, but now we use PVC pipes because PVC pipes do not corrode, so the material in the pipes does not get mixed into the water. Yeah, it used to be it was for metal pipes it was different situation. The material was coming into the water. PVC pipes are very safe to use, but the vinyl chloride is a possible carcinogenic, can cause cancer. So vinyl chloride goes under some changes, becomes polyvinyl chloride. But PVC is completely safe, but vinyl chloride is not safe. So in the factories, in the manufacturing PVC manufacturing plant, workers get exposed to vinyl chloride. So commonly in households, they don't get exposed to vinyl chloride because it's already become PVC. It's fine. Okay, so then I have introduced some a study guide at the end of the lecture notes, and you please go through the study guide. Okay. What did I missed? Okay, some chemistry part. What is organic chemistry? Organic chemistry is where you talk about either carbon or oxygen, hydrogen, which are attached to carbon or just carbon. So something that is related to these is organic chemistry. There are aromatic hydrocarbons, there are aliphatic hydrocarbons. The hydrocarbons are your fuels, natural gas, fuels, petroleum, coal. They are just hydrocarbons, hydrogen and carbon. Okay, carbon carbon products have series like chains. So carbon, one carbon, two carbon, three carbon. So just one carbon has four hydrogens. That's methane. Two carbons with 1, 2, 3, 1, 2, 3, 6 hydrogens and two carbons. That's ethane. Three carbons, butane. Four carbons, propane. So when there's a chain is like C, 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 that's aliphatic hydrocarbon. When it's cyclic, so like on a shape of hexagon, that is a cyclic chain. That's called aromatic hydrocarbon. Okay, when it's a cyclic, then it's aromatic. When it's just chain, that's aliphatic. And aromatic has some smell because they're called aromatic. And aromatic hydrocarbons are a little bit difficult to digest because they're complicated. If you have chain of cyclic chain, so this one and then cyclic and then cyclic, they're called polycyclic aromatic hydrocarbons. They are even more complicated to get degraded into the environment. So I'll give you a very simple example. Diesel exhaust has a polycyclic hydrocarbons, while petroleum, gasoline products has aliphatic hydrocarbons. Okay, so because of that, gasoline is more cleaner. It's cleaner than the diesel because it's polycyclic hydrocarbons. That's why you see that it creates a lot of toxic smoke, very thick black smoke because of polycyclic aromatic hydrocarbons. So that's the difference. Sugar is a organic chemical, while salt is inorganic chemical. In salt you have NaCl, sodium and chloride. There's no carbon, while in sugar you see C6H12O6, carbon, hydrogen, oxygen. So it's organic. So whenever there is a carbon there, it's organic chemical. So that's about chemistry. All right. Um, so get a sense of this chapter. There are a lot of things. There are different things. There are lots of health effects. Go through those health effects. Go through the study guide and read this chapter. There are only two chapters for the exam, so it should be fine. Even though chapters are big, it should be fine because there are only two chapters. And I will post a study guide. There is already a study guide and the end of the PowerPoints for both chapter 6 and 7. I'm going to post a little bit detailed study guide, and tune in for that. And we have exam next week, and also post the PowerPoint that is talking about writing tips, how you write your research paper, what I'm expecting, and things like that. Okay, so tune in and thanks for your support, and keep watching these videos to get an idea about the field of environmental health, this class, and that will help you out, hopefully for your exam and for your whatever your exams and other assignments. I'm going to also going to giving a reminder about the exam next week, so that you don't forget to take exam. Anyway, thanks for watching, and I wish you very good luck. See ya.